So, because a vertical stretch would make it thinner or thicker, and you can't make a line thinner or thicker. So, and because the value of it is at 0, right? So if I take 0 and I times it by anything, it'll still be 0. So the only thing that changes it is the vertical translation right there. After that. We did that. Should be right here. Right here. So I gotta put these down before I write on the board with them, because that's what's gonna happen. So the only thing that affects an asymptote is a vertical translation. Only thing. Okay? Now, your range is based on your reflections. Okay? So if A is greater than 1, that's your vertical reflection technically, right? So if A is greater than 1, A is positive. So it's not going to be reflected in the x-axis, correct? So if it's not reflected in the x-axis, my range, which I'll write on there too, my range is going to be y is greater than my asymptote. That's if A is greater than 1. So A is positive. Or greater than 0, not 1. Greater than 0. Because if your A is greater than 0, it's not reflecting, right? If your A is positive, basically. If your A is negative, so if A is less than 0, you have a graph like this. It's reflecting it. So what's your range going to be? Y is less than your asymptote. So your range is completely based on whether your A is positive or your A is negative. These are just side notes, because everyone forgets this and gets really stuck. So your range, if your A is positive, it's going to be Y such that Y is greater than your asymptote, which you find based on the vertical translation, right? Y, yeah. And if your range, if your A is negative, it's going to be Y such that Y is less than, because your entire graph is going to be below the asymptote then, right? Because it's reflecting it in the x-axis. So it's normally up here if A is positive. But if A is negative, it's reflecting it in the x-axis, so it's going to put the whole graph down here, which means Y is going to be less than, not equal to your asymptote. Now it can't be equal to, because then that would mean it was equal to a line that doesn't exist. So that's why there's no equal to signs. These are just side notes before we start it, because I find that people get really stuck on this, okay? Now, if you look at your transformations, it seems a little weird. The only way you can say how a graph is transformed is if it has the same base. So this little c value here needs to stay the same. This c value here has nothing. It does nothing. It doesn't translate it at all. It needs to be the same. This is your vertical stretch, or your reflection in the. So here is your vertical stretch, or your reflection in. I need to use a small marker. In the x-axis. And this is your vertical translation. Just like they were before. Anything that could be put with the y is your stretch, your reflection in the x, or your vertical translation. Anything that's with your x up here, so see, it's exponential, they'll not have the b out. They'll have the b completely with the x, right? And you'll have to remember to take the b out. Same thing, but that's why I'm saying it's going to appear on at least one question in your diploma where you have to take that b value out. So here's your horizontal stretch. This little b value is your horizontal stretch, or your reflection in the y-axis. And then this is your horizontal translation. So in the exponent is where your x is, right? That's why it's called an exponential function. You have an x in the exponent. So that's where your x is. So that's where your horizontal stretch is going to be. Your reflection in the y is going to be. Your horizontal translation is going to be with that x in the exponent, okay? The value in front, that a, and then your value at the back, that k, are going to be your vertical stretch. or your reflection in the x, or your vertical translation. And this c value is the constant. It's going to stay the same. It's your base. Your base has to be the same. That's the only way we can compare equations is if we have the same base. So look here. Describe how the graph of the second function compares to the graph of the first. We have y equals 4 to the x. So now I need to have y equals 4 to the x still be there, or I can't actually compare these two. They have to have the same base. Okay? So what's changed? Well, the 4 stayed the same, but everything else has changed. I have a 2 in front. What is this? Vertical stretch by a factor of 2. We keep it because it's not with the y, right? We only flip it when it's with the variables, right? It's not with the y, so we keep it. Vertical stretch by a factor of 2 about the x-axis. Transformations never goes away. It's in every unit till the end. The only unit it's not in is perms and comps because you can't transform a perm and comp. Okay? So do they often have just a basic transformation question on your diploma? No, it's going to involve a function of one of the functions you've learned most of the time, right? It could be a basic function, but sometimes transformations, it's always interweaved in all the different units, right? So vertical stretch by a factor of 2 about the x-axis. And what does this 2 do? It's with the x, so it's 2 to the... Which way do we go? Right. It's a horizontal translation to right. Now this one I find always seems confusing because of the way it's written, but if I wrote it in a different way, everyone would get it correct. So this negative is just sitting out front. It's like a -1 because I have to compare my bases to be the same, correct? So I can't look at a 2 and a -2 base. So this base 2 has to be base 2. So this technically is y plus 4 equals -2. How could I write x over 5 better? Because that's just strange. What could I pull it out in front as? 1/5. If I have it as 1/5 x, way more people are going to get it correct. I know they will. That's 1/5, although it does not look like it. So this can't be a -2 in brackets. It can't be. It's first off, it's not in brackets, so it can't be. And second off, I couldn't compare these if this was a 2 and this was a -2. They have to be the same base. Because that 2 does nothing to the graph other than just makes it be the same transformed, right? So this negative in front is not with the x. This is why exponential is actually really awesome, because unless it's up here, it's not with the x, because that's the only place the x is. So this is, are there any vertical stretches? Is there a number in front of here? Is there a number in front of here? No, so there's no vertical stretches. Is there a horizontal stretch? Yes. By, is it 1/5 or 5? 5. It's with the variable. If it's with the variable, we flip it. If it's not with the variable, we keep it. If it's with the variable, we flip it. If it's not with the variable, we keep it. If you still have confusions with that, write it as a little star at the top of every single page you do till it becomes part of your being. If it's with the variable, you flip it. If it's not with the variable, you keep it. So it's with the variable. X is always the variable. You can't move it away. So it's a horizontal stretch by a factor of 5, or 5/1, about the y-axis. When it's horizontal, it's about the y. Is this negative with the x? No, it's not in the exponent, so it can't be with the x. So it's a reflection in the y. Or sorry, in the x. Reflection in the x. Because it's with the y. And then this is 4 up or 4 down? Down. If it's with the variable, you flip it. So if it's +4, it's actually 4 down. This is where people say, Lepp, you're a liar. You told me I can only compare them if they have the same base. This one is the base of a third. This one is the base of a 3. You're a liar. Can I make them the same base? Flip it. So 1/3 could be written as what? 3 to the -1. Which is just 3 to the -x. And now we can compare them. Explain using transformations why the graph of y equals 1/3 x is a reflection in the y-axis. Well, because when you make them be the same base, this one has a reflection in the y-axis. It has a negative x. So let's think about it. Example 3 says, state the x and y intercepts of the following. Remember, if there's no vertical translation, what's your asymptote? Y equals 0, right? If you have an asymptote on y equals 0, do you have any x-intercepts? No, because your asymptote is on the x-axis. Okay? So unless you have a vertical translation, you will have no x-intercepts. So unless you have a vertical translation, you will have no x-intercepts because you have an asymptoted y equals 0. Do any of these have vertical translation? F of x equals 2 to the x. It would have to have plus something at the back, does it? No. It would have plus 0 at the back. F of x equals 2 times 10 to the x. I have a plus 0. 2 times 10 to the x, I have a plus 0. Y equals negative a half, 3/5 the x, I have a plus 0. So all of these have no x-intercepts. Every single one of them. If you have no vertical translation, then your y-intercept will actually just be a, your a value, your value that's in front. Why would that be? Well, y-intercept means what? When you hear y-intercept, you should always think what? Instantly. X equals 0. If you don't think that instantly, you need to think that instantly because your diploma will be horrible if you don't remember that x equals 0 and y intercept. Because when they write y-intercept, they are expecting you to think x equals 0 every single time because you're either plugging in a value with 0 and the y-intercept to get your a value for polynomials, for example, or they're asking you to find the y-intercept, plug in a 0 and get it. So yes, we could use our calculators, but let's just use algebra. So I plug a 0 in for x. I'm going to get y equals 2 to the 0. What's anything to the power of 0? 1. So my y-intercept for the first one's at 0 and 1. What about this one? I'm going to get y equals 2, 10 to the 0. Do not, I repeat, do not go 2 times 10 to the x and tell me this is 20 to the x. That is not 20 to the x. That x is only to the 10. If you're someone who thought you'd put 20 to the x, tell yourself don't do that because that happens all the time. This is not 20 to the x. It's 2, 10 to the x. The x is the only exponent on the 10. 10 to the 0 is 1. So I'm going to get 2 times 1, which is 2. So my y-intercept is at 0 and 2. This one, I'm going to get y equals 2, 10 times 0. So that's 2 to the 0, which is still 1. So this one's going to be at 0 and 1. So do you see when there's no vertical translation on it? The a value, so this would be a 1 in front. This is a 2 in front. This is a 1 in front. This one's a negative a half in front. Your a value, if there's no vertical translation, is your y-intercept. Do you need to memorize that? No. What do you need to know? X equals 0. Plug it in and solve. That's all you need to know. So y equals negative a half, 3/5 to the 0. 3/5 to the 0 is 1. 1 times negative a half is negative a half. So it's at 0 and negative a half. So you just remember that y-intercept x equals 0. These aren't hard. So I want you to describe this. And then here for the following functions, identify the parameters a, b, h, and k. Remember the formula is this: y equals a, c is the constant. I have no idea what it is. It has to just remain constant. B, x minus h plus k. You need to identify the parameters. So for this one, a would be 2 and h would be 4, right? That's what you would take out. Here, a would be negative a half, b would be a fifth, and k would be negative 5. So I want you to do example 4 and 5. Okay. This one is a reflection in the y. And it's a vertical translation 3 down. Because it's not with the y, so you keep it. This one I would have to rewrite as 5, 2 to the negative x. Then I can only tell what happens, because it has to have the same base in order to compare them. So this is a vertical stretch by a factor of 5. Because it's not with the y, you keep it. It's a vertical stretch by a factor of 5 about the x-axis. And it's a reflection in the y because it's with the x. This one is fantastic because you're going to get 6 to the negative 1 times negative x, which is just 6 to the x. No translations, it's the exact same graph. And this one I would write as y equals a half x so that people realize. So it's with the variable, so we flip it. So it's a horizontal stretch by a factor of 2 about the y-axis. What's your parameters and the type of transformation? So a equals 2. So that's a vertical stretch by a factor of 2 about the x-axis. My b is 1, so I don't have to state it. My h is 4, not negative 4. My h is 4 because it's x minus h, and this is x minus 4. So 4 corresponds to h, so h equals 4. That's a horizontal translation 4, right. This one, my a is a half, negative a half, sorry. So that's vertical stretch by a factor of a half, because it's not with the y, about the x-axis. And it's a reflection in the x-axis. So some people will ask me, is this with the x? No. If it was with the x, it'd be in the exponent, right? So my b is 1/5. And that's with the x. So it's a horizontal stretch by a factor of 5, because you flip it when it's with the variable, about the y-axis. And it just says plus k at the back, so plus a negative 5 would just be negative 5. So k equals negative 5. It's not with the variable, so we keep it. So it's 5 down. Then flip over. Which equation represents an exponential function? Is this exponential? Is there an x in the exponent? No, it's a polynomial. Is this exponential? In order for it to be exponential, b has to be between 0 and 1, or b has to be greater than 1, is it? No, it's negative. B can't be negative. Some people will say, well, c isn't exponential because I have a 2 on the denominator. I can write this 2 in the denominator as a half in front. So I can write this as 1/2 in front, 3 to the x minus 2. So it's just an a value. So it works. This one, which equation determines an asymptote? What's the asymptote of that one? It's normally at 0, right? The only thing that changes my asymptote is vertical translation. It vertically translates 1 what? Is it with the y? No, so we keep it. So it goes 1 what? Up. Whatever your vertical translation is what your asymptote is. So if it's 1 up, it's going to be y equals 1. The domain and range. The domain of an exponential is negative infinity, positive infinity. Unless it's a word problem. If my a value is positive, what's my a value in this case? Just 1, right? I could put a +1 in front of here. If my a is positive, my range I said was y such that y is greater than the asymptote, yer. My a is positive. Now, some people will say, well, I'll just punch in my calculator and look. True, unless they put like 4 different variables in there, then you're not punching anything in your calculator, you're just staring at it crying. So we don't want that. We want to know how to do it without just punching in our calculator. Because I don't want you staring and crying. That would be horrible. So, positive a means y such that, for my range, and I'll do it in interval notation too, y is greater than, what's my asymptote? Just my vertical translation. What's my vertical translation? +3. So 3. yer. Or in interval notation, that's round bracket 3 to infinity, round bracket. And it's round because it can't be equal to that 3, because that 3 is your asymptote, right? The whole graph is above 3. The x-intercept, well, plug 0 in for y. Remember, you will have x-intercepts, so you can plug 0 in for y. For now, the way you're going to find your x-intercepts is plugging it into your calculator. When we start doing logs, you'll be able to convert this to a log and solve it. Right now, you can't. So the only way I can expect you to find x-intercepts for now is by plugging it into your calculator. So go y equals 5 to the exponent. If you don't have an exponent that pops up, you have to put x plus 4 in brackets, like this, +3. So if your calculator pops the exponent up, you can just put x plus 3 in that little exponent box. If it doesn't pop the exponent up, you actually have to put it in brackets or you'll get it wrong every single time. It's going to be 5 to the exponent, x plus 4, and +3. Now, do I really need to look at this one? What's my range? The whole graph is above 3. So what does that mean? I have an asymptote here, and my whole graph is above it. What am I going to have for x-intercept? None. The whole graph's above it. So for this particular one, I'm going to have no x-intercepts. Do I always have no x-intercepts? Absolutely not. If this graph was reflected in the x-axis, the whole graph would be below, and it's going to cross the x-axis somewhere, right? So don't just put no x-intercepts like that's the answer for everything. It's not. It just happened to be for the last ones we did. The y-intercept, we just plug 0 in for x. So we're going to get y equals 5, 0 plus 4, plus 3. So it's going to be 5 to the 4 plus 3, which is, I have no idea. 5 to the 3 is 125. 5 to the 4, oops. 5 to the 4 plus 3, 628. What's the equation of the asymptote? It's a horizontal asymptote because it goes through the y. For logarithms, we're going to have vertical asymptotes. Exponential only is a horizontal asymptote at y equals 3. It's always equal to your vertical translation. Then we're going to look at example 9 and then we'll be done. Example 9 says, transform the graph of y equals 4x to y equals negative 2, x plus 5 minus 3. Describe the effects of the domain range equation of the horizontal asymptotes and the intercept. So x and y. I want you to do that one. You're going to have a horizontal stretch by a factor of a half about the y. You're going to have a reflection in the y. You're going to have a vertical translation 3 down because it's not with the y, so you keep it. And a horizontal translation 5 left because it's with the variable, so you flip it. The domain, XER. The range. Is my a value positive? Yes, my a value is a 1. So it's going to be y such that y is greater than my asymptote. What's my asymptote? What's my asymptote? Negative 3. It's just whatever my vertical translation is. Let's see. Intercepts for this one. Your y-intercept and your x-intercept are going to negative 5.4 and 0. I want you to punch one thing in your calculator. So type this into your calculator. Y equals negative 2, 3 to the x plus 4. Punch that into your calculator. Where's the asymptote still at? Still at 4. But what happened to your range? Instead of it being greater, it's less than because you have a reflection in the x-axis. Okay? That's your homework. You have your cum on Wednesday.